हेलो बच्चों, आज हम पीछे जो वीडियोस बनाए हुए हैं उसको कंटिन्यू करेंगे. दैट इज रोटेशनल मोशन. आई वाज डिस्कसिंग अबाउट टॉर्क. तो टॉर्क से रिलेटेड हमने कुछ क्वेश्चंस बनाए थे एंड आई हैव टेकन अनदर वेरी गुड क्वेश्चन. राइट, इस क्वेश्चन को हम सॉल्व करेंगे. क्वेश्चन क्या है? A crane has an arm length of 20 meters inclined at 30 degree with the vertical. It carries a container of mass 2 ton suspended from the top end of the arm. Find the torque produced by the gravitational force on the container about the point where arm is fixed to the crane. And certain quantities are given. G, that is gravitational acceleration, is given. That is 10 meter per second square. And neglect the weight of the arm. So I have drawn the figure according to this question. This is the crane, right? Tentatively, I wanted to make the crane, and this is the arm, right? OP is the arm, and this is the crane, and a container is hanging from the top end of this arm, right? And mass of this container is given 2 ton. Arm length is 20 meters. So this figure I have drawn according to the question. And this is the figure pertaining to pictorial form of the crane and container and all. So related to this, I have drawn another figure showing only arm force in the form of vector. See, arm is this, so I have shown this from O to P as the vector R. This is a position vector, considering this point as origin. So this is one axis, and I will consider this as another axis, x-axis. This is y-axis, right? And 30 degree with the vertical. This is 30 degree over here. So, and weight, it is hanging container. I have shown this by a force. I have to find the torque due to this force, right? About this point, about the point which is the arm is connected with the crane. So this I have to find it out. So for that, to get the solution, what I want, actually torque is equal to R cross F. This is the standard formula, right? And this formula could be written, because all the different form of this formula I have shown for the magnitude of this. Magnitude of this torque will be what? Therefore, I have shown this by the without putting arrow at the top. That is RF sine theta. The same thing can be written as tau is equal to R perpendicular into F, or tau is equal to R F perpendicular. These two plus 1, 3 formula are there. So I will be using all the 3. All the 3 should be used, so that how to apply different formula to get the solution. So first I will use this, and I will show you how to find the torque acting on the arm about this. So for that, you see, what is this theta? Theta is the angle between the position vector and the force. So position vector is this, force is acting over here, so direction of R is this, direction of force is this. So this is theta, right? And what is the measure of this angle? This is theta, this is also vertical, this will also be 30 degree, so theta will be 150 degree, because total angle is 180. So angle between R and F, we cannot take 30 degree as angle between R and F. To get the angle between two vectors, I have already taught you. That is, this is the vector A, and this is the vector B. And tail to tail is connected over here. So this is called the angle between these two vectors. It's not like that. It is head of R and tail of F. So this angle will not be the angle between R and F. So theta is 150, that is the angle between the position vector R and the force F. Right. Therefore, tau is equal to R is, before going for tau, to find the tau, I will find F. So F is equal to what? Magnitude of the force. This is the container and force acting on this is mg. F is mg is the force, right? So just I will wipe it off. Mg is the force. So what is m? That is 2 tons. 2 into 1000 into g is 10. That is equal to 20,000 Newton. This is the force. Therefore, F is equal to 20,000 Newton. And what is R? Magnitude of this, that is 20 meters. 20 meters. This is the magnitude of the length of position vector. So R is 20. I will put over here. F is 20,000 into sine of how much? 150 degree. So this is 20 into 20,000 into sine 150 means 180 minus 30 degree. Sine 180 minus 30, that is equal to, we can write 4 into 1, 2, 3, 4, 5 into 10 to the power 5 into sine 30 degree. Because 180 minus theta is equal to, sine 180 minus theta is equal to sine theta. So that is 4 into 10 to the power 5 and sine 30 is 1 by 2. So 2 and 2 times, that is equal to 2 into 10 to the power 5 Newton meter. This is the answer. This much torque is acting on the arm about this point. This is first method. We can say method 1. Now we will go for method 2. Method 2 means I will use this formula. Tau R perpendicular into F. We will use tau is equal to R perpendicular into F. R perpendicular means what? The length of the arm, that is position vector, perpendicular to the force. Right? So you see, this is the arm length, OP, and perpendicular to F, component of this is this much. Suppose I am writing this M. So OM is the component of this OP perpendicular to F. That is called R perpendicular. So mod of R, right? So this is R perpendicular. I will say this. This is R perpendicular. So OM. So R perpendicular is OM, that is OM into F. What is OM? See, this component, if you are taking, this is 30 degree, so OP sine 30 degree, that is OM is equal to OP sine 30 degree into F. Again, OP is 20, sine 30 is 1 by 2, F is this 20,000 Newton. So that is 2, 10 times it will go, we will get 2 into 10 to the power 5 Newton meter. This is the method 2. For method 3, in the similar manner I will do. I will be writing over here, that is method 3. That is tau is equal to R into F perpendicular. What is the meaning of this? Component of force perpendicular to the position vector. See, This is the position vector. So if I draw a line perpendicular to this, so component of this perpendicular to, it means this part. This P, suppose PS we write, PS. PS is the component of this force along this. Are you getting my point? This is 90 degree. This is 90 degree I have drawn. This is position vector R, and this direction is perpendicular to the position vector. Component of this F along this will be F perpendicular. बात समझ में आ रही है बेटा? इंपॉर्टेंट चीज है. मैं तीनों मेथड क्यों यूज कर रहा हूं कि भाई आपको कंसेप्चुअली चीजें क्लियर होनी चाहिए. एफ परपेंडिकुलर का सिग्निफिकेंस क्या है, आर परपेंडिकुलर का सिग्निफिकेंस क्या है, पिक्टोरियली इसको फोर्स के फॉर्म में कैसे दिखा सकते हैं. दैट आई वांटेड टू शो दिस टू यू. सी दिस लेंथ पीएम इज द फोर्स, दिस लेंथ इज शोइंग पीएम, and component of this along this is PS. So we will write what is the length of PS, that will be F perpendicular. So here R is 20, F perpendicular if you look at, this is 30, right? This is 30 degree, so this will be 60 degree because 90 degree I have drawn. This length PM, PS is equal to what? PM cos 60. I will write PM into PM cos 60 degree, because PS upon PM is cos 60. In this right angle triangle PSM, PS upon PM is equal to cos 60. So PM cos 60 is F perpendicular. That is 20 into what is PM. PM is the force and force is 20,000 Newton. So 20,000 I will write, and cos 60 is how much? Cos 60 is equal to sin 30, that is 1 by 2 again. So 2, it will go 10 times, we will get 2 into 10 to the power 5 Newton meter. This way, one question in 3 different way we could find the torque acting on the crane arm. So this I wanted to tell you, all the 3 methods we should be able to use, that I wanted to tell over here. So some more question I will be solving. आगे और क्वेश्चन सॉल्व करेंगे, नया कंसेप्ट बताएंगे. तब तक के लिए गुड बाय, टेक केयर ऑफ यू.